Hello, my dear students again, and it's class number 15, it's lecture number 15, and I prepared the pictures in order to remind where we stopped yesterday for you, or maybe right now, maybe you're watching them one by one. We've been talking about sheet metal stamping, and sheet metal stamping remind you in our diagram of general sequence or transformation, sheet metal stamping may be separated transformation of shape and transformation of volume. Yesterday, we've been talking only about deformative methods, methods of deformation in sheet metal stamping. And let's hide this temporarily. No, I hope you do remember. Actually, it comes about equipment press. In this equipment press, we need to install special tool, punch and die block, and usually punch and die block, they are hidden inside of die. But some machines, they realize, let's say, direct using of punches and die block, because they are universal machines. I hope you do remember. V-bending machine, rolling machine, they don't need some special tools because they have set of tools supplied together with machine. And actually tools present, but they don't need tooling because they are like inbuilt in machine already. And what I need you to show and to remind additionally, yesterday we talked about different techniques of sheet metal stamping and about some problems that appear during such techniques, and about one more important thing, that actually whatever we do, besides of satisfying demands of customer and demands of program, I mean terms and amount, we also always think about ourselves, how to save money, labor force, how to save time for manufacturing, and additional point for pre-production, because for some kinds of manufacturing you may start practically immediately as only you wish. For instance, this rebending, it's demand you a couple of hours to prepare because you already have everything and you need only to adjust some parameters in CNC controlled rebending machine. And when it comes about using of special dies, special or half universal like it was with dies with rotatable elements, first you need to design the die. You need to design this die some months. You need to produce die. You need to test this die, and only after you may start the work. But after this, of course, your work looks like shooting because of press working quickly. But before this, you spend money, time, labor force for some months. You investing all this, and only this, and only after you will have some payback, let's say. But this payback also you need to understand, if it comes about programs in thousands of elements, of course, it's really paid back to you that you spend this time for pre-production and money for pre-production. In case you need to produce some pieces or some hundreds of pieces using of special dies, maybe not rationally in this case, not necessary to calculate actually what will be more expensive. And each time we remember that the same thing may be done as a rule, may be done by some different techniques. And question is how providing the same quality, how to save money, how to exclude some additional problems while processing, and how to do everything with the same quality, but in more simple way for us. Very well. And where we stopped yesterday, what is the problem during sheet metal stamping in case of bending, especially in case of some techniques of flanging and forming? I hope you do remember it comes about spring back effect. When material is spoiling the shape after their, here is explanation just to remind you, when material may spoil shape after material was bent or after material was deformed. And another direction of our, besides of this struggle with the spring back effect, another direction of our work, let's say, is about saving of materials, about saving of resources, not materials, saving of resources, saving of um, whatever resources, money, time for manufacturing. And in this meaning, what we are usually trying to do, once again, normally sheet metal stamping is fulfilled by special tool which consists of two halves, punch and die block. What if we have no another choice besides of like forming the part from sheet metal, but we'd like to save money because for instance, I'm already reminded you, for instance, we need to produce couple of hundreds of those parts, but die, couple of two in die, uh, punch and die block, they are for some thousands of them. And things seems like we do not use their product life, their resource on the whole. How to save money? Let's reject one of tools, either punch or die block. Usually it comes about die block by the word. Let's make die block soft one or half soft. What does it mean? What right now I keep in front of you a couple of pictures from Michael Grove book. In case you're interested, you may read more immediately in this book that I already sent to you. It's so-called stamping by rubber. It's not really rubber. Usually it comes about polyurethane. It's called here rubber pad, but usually it comes about polyurethane. And stamping by water or hydroforming. When I said that punch is hard, made of metal or wood, and die block is soft, I meant either it's some hydraulic fluid of different types of machine or it's polyurethane. And let me to show you one more way, one more rather popular in real life way and usable also in some aircraft manufacturing parts. It's in English it's called spinning. In our understanding we call it roll drawing, and in some English literature I also seen it like roll bending. Sorry, not roll bending, roll drawing, something like this. In contrary to deep drawing, it's not fulfilled with punch and die block that moves linearly with respect to each other. It's use rotary motion of something, it's called mandrel here, of something that is actually work as a punch. You see why it's called mandrel, because the whole machine is more similar to the turning machine, to the lasering machine. And this lasering machine, they use, when they use something like this, it's called mandrel in turning machine. Maybe that is why it's also called here mandrel. But function of this mandrel, it's like a punch. But beside, in contrary to what we did in usual deep drawing, for instance, here is instead of intruding the punch into the metal, punch is rotatable, and you use special roller tool in order to make material flow. Originally it was flat sheet, piece of flat sheet, clamp it to the punch, to the mandrel, and together with rotation, step by step, portion by portion, it will be formed over this sponge. If necessary, it may be even more complicated shape, and the whole this mandrel punch, it's made separatable. It consists of some, it's assembled from some pieces, and in order to remove it next from the half closed shape, now do imagine that here we have more complicated shape. We just separate these pieces and remove it one by one, and due to this you have more complicated parts. Well, that was about sheet metal stamping deformation operations, which are really extremely various, around 20 different names for them with variations. And all this thing, it's not everything about sheet metal stamping. Where this everything? Let's come back to our slides again. And we have seen in a picture that practically the same The same scheme seems like dia block, punch, piece of sheet metal, but it's maybe finished either with deformated part with some deformation like cap-like part, or it's maybe finished with cutting of the shape. No, here is it's shown cylindrical shape, but this cylindrical shape maybe not cylindrical, it's maybe whatever shape, depending on what hole shape and punch shape at the butt, no, at the butt, at the end of it. Um, you may use practically any shape and very different sizes available. Uh, it's cutting process by die. And I will come back for scheme in couple of minutes. But right now, let me to remind you maybe things that you already understand. How we may cut a sheet, how it's possible to cut a sheet. And moreover, we also should think not only about the sheets, we need to think about profiles and pipes. No, we have a lot of different ways to do it. The most obvious, do imagine the sheet of paper, the most obvious way to cut it. What is the most obvious? Scissors, yes. And the same we have for sheet metal. We have different machines which are called scissors. No, despite of simple scissors for metal, they look exactly like normal scissors we get used to see, but blades of them are much shorter and much more massive. So cutting is possible by scissors, sheet metal, I mean, by scissors, by saw. Saw may be of different types also, and scissors may be of different type. What right now you see some variants of saw and with their names. And what is right now? It's so-called band saw. Band saw. It means that usual saw moved by closed ring and it's permanently rotates here, and you need to move the workpieces along to this ever rotated saw, and you need to move it and cut something. That one is rather dangerous to employ. I hope it's understandable for you. But that one may cut both sheet, pipe, not both, three of them, да? Sheet, pipe, profile, and it's may cut by any shape practically. No, of course, it has some limitation on radii, on angles, but it's practically any shape available for such device. But it's manual. Uh, what do we use if we'd like to cut straight line? Straight line may be cut immediately. It's called guillotine shear. Guillotine shear, it's the sort of scissors. Also somehow remind the bending machine, but instead of punch of complex shape and we cut die block, there will be two plates, and these two plates they are also sliding with along to each other and with appropriate clearance gap, and due to this you may cut in a second, in the portion of second you may cut the very long sheet. For instance, you may cut strips with this guillotine shear. Is it possible to cut something less, not sheet, but some short parts with this? Yes, it's possible, but it's not rational because you are spending the force, the energy, and time amortization of very big machine for insufficient things. Uh, Also, variant of such guillotine shear, what you see on the right, it's also guillotine shear, but manual one for little things, which don't require some significant efforts. But do imagine that you insert it into this right one. It's easy to imagine, I hope. That on the left you see the same machine, but plates are more massive inside. Of course, it's working. No, that one maybe is under numerical control at all, depending on. Yes, it seems like Seems like it's CNC controlled. It means that the back stopper, this back gauge that we have seen in V-bending machine yesterday, back stopper may move automatically according to the program. And this thing, or this machine, Helitin shear, it's called. This Helitin shear, it's protected with, you do remember this word, foolproofness, with the special grades. It's protected from the curiosity of some employee in order they do not squeeze their fingers in this dreadful machine. And that one is open, everything is visible, easy to imagine. Let's imagine that you place it there, a pipe or piece of profile, and cut it. Imagine it, yes? What do you see at the end of this pipe? It's jammed. It's spoiled in cross section, and the piece, this work piece, already spoiled. So Helitin shear, it's not the way to cut something like this profile or pipe. It's clear. So it's limitation already, we will remember. But how to cut profile? Here is, we call it anchor saw, and in English it's called falling saw. Falling saw, practically you see what? You see something like mill, disc mill, or it's maybe abrasive disc here. And this one, it's moved down and up. On the table you have here is to place profile or pipe. This one reliably and quickly cut any profile, any pipe for you, practically without spoiling the cross section, especially if you use proper supportive tooling on the machine. By the word, what is it? Altogether, it's equipment. This disc inside, it's a tool, yes? And in case you use some supportive jigs, it will be tooling. No, this machine, how funny it sound. No, maybe you have seen somewhere in your life. I trust, especially boys. I don't know, in a garage, for instance, if you have machine or you have experience of mechanical work or some metal work with father or someone else, you have seen such machines, but not stationary. This disc saw, it's maybe called. And this disc saw, typically it's used for cutting something like extruded profile and pipe, but it's not rationally to cut a sheet by this thing. No, it's do some slot, and next you need to replace it and do some slot. It's not rationally. Of course, if you have nothing at all, you will use it. But in real manufacturing, quite clear, it's not usable for profiles and pipes. No, that is on purpose. I try to remind you about some things may be done by different ways, but not all the ways are rationally physically able at all, maybe. No, do imagine that you are trying to cut the piece of glass in Helitin shear. What happened in this case? It's too fragile. It's not cuttable by shear cutting. It will be just broken. And shear cutting, it means that you direct the force and apply, let's say, the force by shifting the layers of material to direction perpendicular to the thickness. No, I hope you have imagined it. For those who not, let's use pictures. Maybe I did it too much. Wait a second. Bulk deformations, not enough. Так, do help me, please. Almost here. Sheet metal working. Oh, here is the scheme of shearing. And no, you see Helitin shear, but it's still called die and punch. No one actually call it like this in real life, but really they are die and punch. You see it's in cross section, side view and front view. And here is result of cutting in a die. Cutting in a die, what I talked about shearing. It means that instrument make layers of material to move in directions that perpendicular to the thickness. Так, I hope that is understandable for everyone. And those who in technological groups like 133, 1332, 1333, they will study it with me in more detailed way. But in practical class, we will talk about more. And moreover, about this shear cutting, I will give you a practical task with calculations. I hope you will like it. It will be not so creative as designing of airplane, but maybe it will be much more easier for you. And let's come back to my picture, to our picture. So now we are already in transformation of volume. Either we're trying to subtract something, it's subtractive techniques, so called, or we try to add something, additive manufacturing techniques. I wrote them additive manufacturing on purpose because in English it's also called like this, AM, additive manufacturing. No one call it just additive technique, additive manufacturing. And subtractive techniques, they may be by the nature of energy of tool that we are going to use, they may be. Look at this. I placed here some groups without practically without explanation of without listing the names. These names we will pronounce no sometimes, but it's not possible to squeeze everything here in one page. It will take maybe a half of kilometer to mention all these techniques. Look, subtractive techniques, mechanical group. Mechanical, it means that we have some metal, typically it's metal tool made of metal. Electrical, what does it mean? It means that we are going to use electricity to cut something, not in terms to move tool which is electrical, which is made of metal, but to use electrical discharge as a tool, actually. Electrochemical, it's called electrochemical in English, so I wrote it here like electrochemical, but in our language it's called electromechanical. It's more easy to understand by this name, electromechanical. What is the story? What is the essence? It means that there we use conventional mechanical tool, no, like grinding wheel, for instance, or the same mill, disc mill, for instance, but with addition of electric electrical liquid. Let's say it's not electrical liquid. It means that it's able to provide electrical contact, such a liquid, with higher quality, and cutting will be inside of special liquid with additional acting of electrical discharge, but by mechanical tool. Chemical etching, it's called in English, chemical etching. We usually call it just chemical milling. It comes about just chemical dissolving of material in aggressive mediums. No, like in acids, for instance, in boiled acids by the word. And next one, next group I wrote, so-called beam techniques, beam methods. Very popular, I trust. Laser cutting and electron beam cutting or electron beam machining I wrote here because actually both, most of these techniques, they may be used not only for making cuts, but also they may used for making joints. And some of them, they may be present in this group. They may be present in the group transformation of surface properties because they are also used for making coatings. And some of them may be used in transformation of spatial position in terms of making joints. What in particular, look at this. What we get used to see this collocation, arc welding, yes? But arc cutting is also possible, and moreover, it's widely used, so-called arc gorging by carbon electrode. And the most popular here, electrical, they are so-called electrical discharge methods. I wrote here electrical discharge plus arc plus and plus another one. Actually, it's not the only. And electrical discharge also may be divided into some groups. And finally, I wrote the group heat methods here. Heat methods, it means that you are using heat directly, no, whatever sort of this heat, for instance, oxyfuel cutting. When you use special, no, practically the same equipment and tooling that for oxyfuel welding, maybe you know it, like with open flame, welding with open flame. But the torch itself, no, the instrument that employee take in hand, it will have additional channels with additional supplying of the air, and whatever you melt there, no, you know that this technique of welding, maybe you know, I think it's relied in melting of material with next fusion and solidification. What you have melted, you may either use left it for solidification or additional channel with injected air with a high velocity. You just blow it out from the place of melting, and due to this you have cuts, even like this. So all these groups, we will try to see in pictures right now. All these groups, they are differ what with. Of course, they are differ with cost, quite clear. They are differ with the time that you spend for that or another operations. In particular, electrical discharge machining, it's extremely slow. It goes by hours, in contrary to mechanical machining, which goes by minutes. In contrary to the shear cutting, which may be fulfilled during, that's it, it's done. And chemical etching also, it comes about hours, but it's work with huge areas. It's very convenient when you need to mill, no, take out some material to remove some thin layer of material or thicker layer of material, but in great area. And in this case, chemical etching is effective. No, time spending, it will be effective comparatively to conventional milling. Some techniques, no, once again, do imagine that we are trying to cut mechanically the piece of glass. More probably it will be broken. No, in case of using a special grinder and not completely with its cutting, but just scratching it, next we broken it with not reliable results. But we have another techniques to cut it. In particular, heat methods may be used, laser cutting may be used, and so on. Electrical discharge technique may be used. Yes, it's slowly, but results are with higher quality. Results are guaranteed. But again, mechanical technique, they are very short in time, and due to this, practically they and not so intensive heat energy they are used. Of course, any breakage of material, any plastic deformation, especially when it comes about quick plastic deformation, it goes with ejection of heat. Heat is appearing in the process because process is too quick, and each material, it has its unique speed of let's say inner transformation. And in case you follow this special for each material speed for inner transformation, for inner deformation, in this case material practically is not heated up during processing, and in this case it's so-called superplasticity of material. It's the highest effectiveness of material deformation, cutting. Usually it's used for deformation, of course. But if you increase the speed of processing, it's like try to imagine how you feed the child, the baby, and babies chew very slowly. In case you will supply spoon by spoon to the mouth of this child, in some minutes it will, no, not minutes even, in the third or fourth spoon, it just spit it out, this food, because it's not able to take it inside of his or her cheeks. something similar happened to material. If we are too fast in applying of energy, this energy is appearing back in the view of heat. It's like dissipated into the air or to another media. Some portion of energy we have supplied is spent to deformation, including the ultimate deformation that resulted in separation of material, breaking of material, cutting. And another portion of energy is just dissipated to the air or whatever in the view of heat. And what did I mean? In case you use another kind of process of cutting, not, for instance, not mechanical cutting, laser cutting or EDM cutting, you need to understand that you may use unique materials, for instance, for this. No, I mean hard to machined materials. Hard machined materials may be cut by these ways. Moreover, some features may be different. When you're cutting something by milling, in corners always you have fillets which equal to radii of mill. It's easy to imagine. When you're cutting something by electrical discharge machining like wire ADM, the thickness of wire that you use for cutting, you're cutting literally by wire, but thickness of this cut is sometimes less than human hair thickness. And when we're cutting with laser cutting, also practically there is no thickness. But no, laser cutting it's more speedy than wire ADM, but wire ADM left surface a bit spoiled surface and some layer on the part on workpiece spoiled by the heat. It's some zone that changed by the heat. I hope you do remember inner structure. If you exceed the temperature, if you over the temperature of so-called collective recrystallization, it's in a range 0.5, 0.7 of melting temperature for different metals. In this case, you initiate the changing of inner structure in superficial layers. And laser cutting will be worse in this meaning. It's faster than wire ADM, but it's leave you more spoiled layer on the surface. But both of them, in contrary to conventional cutting, they are able to produce practically minimum zero radii, straight corners. Conventional milling, it's not available such an option. But for shear cutting, it's already available. But shear cutting working only with thin materials. Sheet, maximum plate, maybe in some cases. Sheet, profile, pipe, yes, shear cutting, it's for it. But not for complex spatial shapes. Okay, let's come back to our slides. Instead of listening my CS Rising, let's try to see some pictures. Well, you already heard from me about shear cutting and another variant when we're using the blade for cutting. Blade, it's like the sort of knife, but much more massive. And this blade may work either it's move, no, practically it's move linearly along the surface, but some machines, sorry, let's come back again to the scheme. In the scheme, look, you see the name conventional cutting in mechanical group. I should say what? These techniques that you get used to see and to use, turning, milling, grinding, drilling, whatsoever, they are normally called conventional cutting. Shear cutting, conventional cutting, everything else is called non-conventional cutting. All these techniques of separating of material which are hidden in another groups, they are united with the name non-conventional cutting. And conventional cutting itself also separated at least onto two different groups. Blade cutting, cutting using blades, and abrasive cutting. Maybe I'm too speedy in the explanation. And we need to ask help of our theory of metal machining. What? Metal machining, and look, machining processes, material removal processes. Here also not everything is mentioned. You understand, I hope. And the first some subgroups, this conventional cutting, conventional machining. No, this author place abrasive processes separately from this. Maybe such classification also take a place. And what do I said? That we may use either blades or abrasive materials tool which made either in the view of one or some blades, and tools that used in the view of thousands of those blades, but they look like little grains combined with binder. And these thousands of grains, which are actually tiny blades combined with binder, they may be made in the view of tool. It may be cylinder, it may be disc, it may be flat, whatsoever. But idea is the same. You are scratching material, you remove material by blades, either they of big size or they are of tiny size, and simultaneously thousands of them working on the same surface. What happened? Someone writing in, I will check it later. It's TikTok. Someone writing in TikTok. People have activated. Maybe you did your tasks and inform me about this, or asking the questions, maybe. And look at this. Right now we see something like mechanics of process of cutting, and we see that cutting with appearing of chips. In contrary to shear cutting, also it may be called like shear cutting, a cutting with chips. This conventional and abrasive machining, it may be called cutting with appearing of chips. Different types of chips, different types of loading, and different types of processing right now. And what do we see? I said it will be a blade, and this blade cuts something. Variants may be one blade, two blade, hundred of blades. No, hundred of blades is too much, of course, it's overesteemed. Look, process which is called turning. Blade move linearly, and the workpiece is rotated, turning or lasering. And while turning or lasering, you are cutting a piece, a layer of material by spiral motion altogether. It looks like spiral motion of tool along the workpiece, but really the spiral motion, it's superposition, this summarizing of linear motion of tool and rotational motion of the workpiece, turning, or another name in English, lasering. One more way, when you have some blades, we see milling process at the bottom of various tab, but no, here is very similar, as you might see, to the drill, this technique, but it's not a drill, it's a mill. And here is also the mill. Mill may be of different types, depending on where these blades, on which side of the mill, and what is the shape of the mill. That is in particular so-called end milling. Here is the face milling, when mill cut the surface, but certainly it comes about combination. You see cutting edges, these blades in the view of cutting inserts, they may cut both bottom and a side, of course. When we see something like this, what right now you see actually turning machine, but in turning machine there is process that you know as drilling. Why? Because drilling maybe doesn't matter whether you rotate the drill or you rotate the workpiece. And so you may use drilling machine for making holes by drilling, or you may use turning machine. And instead of rotating the tool will be fixed. It's make only linear motion inside the workpiece, and workpiece rotates. seems like the same. Finally, it's the same motion, rotation of the tool, practically rotation of these blades with intruding them into the hole. Well, once again, look, this conventional cutting. Let's talk about conventional cutting by blades. Just by blades. What it comes about? Turning when workpiece rotates and a tool do linear motion. Milling, it means that you have some blades already. It's multi-blade. No, it's called in English. It's called single point cutting for turning, for instance, and multi-point cutting for drilling, milling, and some other techniques. With this multi-point cutting, it means that you have some blades, and these blades in contact with the part, and it's necessary to do what? No, at least it's necessary to move them along the path. Mill itself, the tool, mill, it rotates, and it may move either, depending on the machine actually, either mill together, mill is inserted into spindle of machine, either mill rotates and move together with spindle, or table of machine is movable and table move the workpiece with respect to the mill, which rotates. Or in more complicated machines, it will be realized everything all together. Mill rotates, mill moves, spindle may deviate to different angles, table also movable, and table also may deviate to different angles to process complex surfaces from the same position. No, like without changing of position inside the machine. So once again, turning, milling, at least. Next, we need to process holes. No, everyone knows such a name, drilling. But drilling, it's not the only way to process hole. Drilling do hole in so-called diff material, but drilling it's very rough operation. Rough in terms that international tolerance grade achieved by milling, no, 12, no, the best way. Actually, 14, 15, in the best case, it will be 12. But what if you need better hole? For instance, for so-called tightened bolts, you need 7, 8 quality grade, international quality grade. But drilling provide you only 7, only 12 or 14 even. What should we do? In this case, we have another techniques. Let me to show you. Wait, where it disappeared? Maybe here. Oh, yep. Да, you see here is it's so-called single point cutting tool, removal of metal, different variants of machine. Actually, it's not because it's different cutting. It's very similar in idea, but different realizations of machinery itself, and much more variable is multi-point cutting. Oh, milling we have already seen. Whatever it's written here, surface, slot, dovetail, from cutting, it's milling. It comes about milling of different shapes. One more way, drilling, and with drilling, also after drilling, which has only two blades, normal drill, it has two blades at the bottom. We also have, it's called countersinking. Countersinking, it's very similar to the drill tool, but it has more blades, and due to this, it's more accurate and able to provide you better surface finish, higher accuracy level, and so on and so forth. Reaming. In case of reaming, we have some dozens already of blades, and they are linear. They are here on side of this rotatable tool. Reaming may help you to increase the quality already up to 6, 7 quality grade, and practically ideal surface finish even without grinding. What is next? No, I hope you understood already out of my tiered a bit explanation that the more blades, the better. Why it's better? Because you may afford cut thinner layer of material by each blade, and due to this, finally, you have higher quality and higher surface finish. So 2 blades in drill, it's rough processing. 5, 7, 10 blades at the bottom of countersinker, it's already better processing. And when it comes about couple of dozens of blades in a reamer, it's already practically ideal processing. But do imagine what did I said about abrasive cutting? What if you have thousands of tiny blades? No, certainly it will be much more better. Yes, of course, but also we need to remember what the thinner layer of material we able to cut, the longer process of cutting. No, if do imagine that you cut something with thick piece, or you cutting it with thinnest layer one by one, how long it takes you. And on one hand, seems like more convenient to do something faster with single point or multi-point like milling. But on the other hand, if you'd like to have higher quality, you need abrasive tooling to use. How this problem is solved, you already understand by combination. First, we remove some layers with quick techniques, let's say, and next we continue with more multi-blades tool, and finally it's maybe finished with abrasive tool. It was about making of cylindrical hole, but what if you need non-cylindrical hole? Maybe you need triangular one. How to make it? Triangular, rectangular. No, if we still continue to talk about the conventional milling by blades, by appearing of chip with making of chips, in this case, technique which is called broaching. What here is, you see, the broach. Here it's shown. No, what look at this broaching machine, and seems like they're trying to make a cut, rectangular cut here at the end of the workpiece. And in cross section, what do we see? We see tool which has some teeth, some blades, and each blade it's a little bit far protruded to the workpiece. It's like far, far, and far each of them. But really, this difference between them it's some microns. And really, you have some dozens of these blades along the way. Once you are passing with this broaching through material, once one linear motion, but as you pass it already with 20 different tools, for instance, if you have 20 blades. So very effective process, seems like in terms of time spending, but you understand also has limitations. Of course, everything has limitations. And this process, it's typically used for complex shapes cuts and for higher demands of quality. It's not the only way to make rectangular holes, triangular holes, but in conventional machining, broaching is practically the only way. May we do it by milling? Yes, we may, but milling will leave some fillet in corners. In case you are demanded zero fillets, for instance, or practically zero fillets, milling, you may do preliminary milling or drilling, but next we goes into broaching and maybe finally even additionally in abrasive cutting. Very well. Next. No, I hope you understood it. If necessary, we will see some pictures, some slides in another set of slides right now. Right now, let me to see what is the time. Whew, scared. And next in list was EDM, electrical machining. What does it mean in the electrical? It means that we are going to do something like explosions on the surface. Little electrical explosions. We are going to use, our tool will be electrical arc. We are going to use energy of electrical arc in order to melt material on the surface and to remove it. Melt and remove, melt and remove. And these techniques, no, I will show you only EDM right now in scheme. Arc cutting is very, it's very similar to what I said. Like you are over melting material, just conventional arc welding to imagine, but like you over melting material in the area where you need to cut practically. No, and additionally, it's maybe use some, for instance, compressed air to remove this. No, typically, it's just over over melted in gorging process. And let's come back to EDM. What is this EDM idea is? You see two big groups, RAM EDM and wire EDM, where slides are. And to understand what it looks like, now we see EDM of RAM type, what it looks like. Here is workpiece. Here is workpiece. It's placed into bus, into container with special liquid. And this liquid, you see, practically cover all the zone. And what it's necessary for? It's necessary to serve as a media for providing the electrical contact. And here is, it's called electrode, but this electrode, it's repeat the shape completely of the cut or cavity you need to process. And this electrode, it's gradually, slowly intruded into the workpiece, make it to repeat the shape of electrode. Why? One pole of tool usually switched as electrode, and that one switched as ground, but they are elements all together. They are elements of the same electrical chain. And if you supply energy to this electrical chain, it's appear, and we have clearance here, we have gap, and it's visible that we have gap. If this gap is in appropriate limits, usually it comes about dozens of millimeter up to 5 millimeter maybe. It's already it depends on what you do, what material, so on and so forth. These recommendations, they are exist in literature. Story is very similar to arc welding, but you need to understand this arc, little tiny arcs appearing and disappearing all over the surface of this RAM. And additional motion of liquid make products of melting of metal to be removed from this area, to be removed immediately to the liquid itself. Well, and due to this tiny micro explosions on the surface and motion of the liquid, finally, in some hours, you will have the cavity or hole, which practically repeat the shape of the punch with tiny deviations that already, like, it's already included in the shape of the punch. In order you have shape in the workpiece that is given in technical documentation. Problem is, some hours, crazy people, you have nothing to do. Some materials are so hardly processed that it will be more feasible to use this technique with providing the quality, with all the sizes and so on, than to broke some hundreds of mills, of conventional mills, and finally not to have proper quality on the surface, because material may be hard machined, so called, hard to cut materials, and material may be fragile at the same moment. Fragile, it means that it will tear off pieces on the surfaces. The whole grains may be tear off it from the surface. And finally, if even you have necessary sizes like this, seams like this, you have necessary sizes, surface roughness does not correspond to their demands of the one who demand you to produce it. So once again, all these techniques, they to compensate problems of one another. If something is either physically not possible to be cut by conventional cutting, or it's too expensive by conventional cutting, not feasible, not rational to cut it by conventional cutting. In this case, we go into another techniques. And this another techniques, it's using this RAM and wire EDM. That one, I hope, understandable for you. Wire EDM is something fantastic at all. Oh, I forgot to mention there one. It's maybe considered like abrasive cutting. I will show you, and we will try to find the place for it. It's so-called jet cutting, will be. We may even separate it into separate group, but really it's mechanical cutting, jet cutting. So What does it mean wire machining? Let me to show you a real one. I hope I will find it quickly. Найдись быстро. Here is. Ha! Wire cutting. Here is, you see scheme of wire ADM. I need you to understand it's not one piece of wire. We have two rolls of wire, extremely thin, and they are permanently rotated. Somehow reminds the bandsaw actually, when you rotate the closed ring of saw, and here you permanently rotate this tiniest thickness wires, barely visible actually. When we brought to students this material, it's barely visible, so thin is it. And additionally, these rolls, they may float, let's say, in the place where they are, in order to change direction, in order to change angle of this cut. And finally, you may do unique shapes actually due to this. And these unique shapes, additionally, they may be very complex. You may use it either for making holes or something that you cut from the plate. It's your final part if necessary. And these complex shapes, they have very high quality of surface. And additionally, you may afford practically zero radii. Look at this. In the scheme, it's theory, да? But what about real life? No, that is, you see example of EDM wire cutting for dovetail, it's called, of engine blade, for clamping place, for fixing place. And here is, you see example of real, this maze made by wire ADM. You see the wire itself is it's visible like thin beam of the light. I don't know. No, it's visible here. Well, let's come back to this place. I said I forgot. Look at this. I forgot. Yes, I forgot something else in that scheme. Arc cutting and one more. It's called arc cutting and plasma cutting, but story is the same. It comes about using of electrical arc energy, micro explosions, as I said. Right now, what do we see? How do you think? What do we see? Maybe you already understood. It's jet stream of water. It's water, but look what it looks like. It looks like very thin needle. Yes, there is the sort of needle in this case because it's with very high pressure. And additionally, it's stuffed with very thin sand in order to work as an abrasive. It's called abrasive slurry in English. And no, may write it for you. If you're interested, you will open the book to read. And this water jet cutting, it's a great thing in terms. Also, it's give you opportunity practically of zero radii. It's maybe resulted. Look at this. It's some impeller made by water jet cutting from a piece of plate. To imagine that you do something like this by milling. And in addition, after you do it by milling, all this plate, it will be just chipped. I mean, it will be transferred into chip, transformed. But here is you still have a piece of plate available for next cutting, for instance. And at the same time, you have this impeller. That was done by water jet cutting. And what is higher here is, it's like comparison example of two kinds of cutting of different groups. Let me to show you where it's supposed to be. Electrical cutting, arc cutting, and here is must be also plasma cutting. I will edit after, will not spoil your time right now. Plasma arc cutting. No, plasma arc cutting, it's also arc processing, whether it's arc welding or plasma arc welding. They are in the same group, but due to some changing in, oh my, not like this. Due to some changing in equipment, additional tricks, let's say, we have much more higher energy and much more higher temperature and higher effectiveness. With spending, no, seems like with spending of the same electrical energy, you will have additional profits, let's say, when you're using plasma arc welding. It's in electrical techniques. And next to it, you will see laser cutting results. It's in so-called beam methods because they use beams of, no, laser use beams of concentrated light, and electro beam machining, which is not shown there in slides, but maybe we'll see some results of them in practical class. Electro beam machining, it's operating with the thin beam of electrons. It's directed motion of electrons, speederized, accelerated with very high energy, and due to this, it's able to cut extremely hard material. It's able to cut extremely thin holes, some difficult slots, so on. But electron beam machining, it's accompanied with stiff X-raying. It's dangerous for human, for surrounding. It's extremely dangerous as well. Great thing, but dangerous, you see. Laser cutting, great thing, not dangerous. You typically not much dangerous for people and surrounding. Energy effective also, everything is great, but it's leave the spoiled layer on the surface. Once again, whatever technique you use, it has strong and weak sides, let's say. It has advantages, disadvantages. And it's necessary to understand each these advantages, disadvantages, peculiarities of each technique in order to understand which one to use. Of course, quite clear that why it's called conventional cutting, conventional techniques, conventional milling. Conventional, it means most widespread, and this convention has been known already for hundreds of years, and new one, most of new ones, they appeared with so-called technological revolution in 19th century, and the most of them, you should understand, the most of them not available, you can't use them if you have no power plants. No, some conventional techniques like turning and milling you still may use if you have no electricity, because you may use manually, mechanically driven machine. It's very funny, but in 17th century, in 18th century, turning machines, they were similar to old-fashioned sewing machine. Let me to try, but I'm afraid it will be, wait a second, sewing machine with leg drive or foot drive. I don't know how to write it correctly in English. Never thought about. With, no, it's electrical one. No, that one old-fashioned with oh, here is. Da. Da. And here is at the bottom we see pedal. Next we see wheel transmission is called, to the wheel of machine. You may rotate by hand manually, or you may move pedal here, and motion of pedal is transferred to the this transmission, and transmission rotate machine. Would you imagine something like this, but it will be turning machine instead of sewing machine? So some conventional techniques, in case you have no electricity, like manual drilling, manual turning, they are yet available, but more electrically powered techniques like this EDM, beam method, so on. No electricity, no machining. Wait a second, let's come back. Look at this. On the top you see laser cutting. At the bottom you see plasma arc cutting. And pay attention, like the difference in the thickness of cutting, and pay attention to the fact, here is, look. What did I said? Spoiled material. You see what area of material, no, by color it's visible. this material was overheated in the process. Of course, it's cut great thickness. Maybe it was hard cut material. In case you use milling for such thickness, mill should be in diameter at least equal to the thickness of material. So do you imagine how much material you will waste while milling, in contrary to this plasma arc cutting? But plasma arc cutting, you see, it's resulted in overheating of material. What we see here, like additional flash, scratch, or whatsoever, it doesn't matter. It's maybe next removed by abrasive material machining, or by any mechanical manual machining, like filing, for instance. But seems like extremely effective, quick, and the saving of material. But on the other hand, what is now in this zone, whether it corresponds to specification or not, that is under question. So all techniques have advantages, disadvantages. You understand already. Maybe you understood it before me, because you are not little children, first years. And let's see some slides here also. No, once again, it's jet cutting on this side, and here is something which is called electrical etching. Look, here is electrochemical machining, electrochemical etching there. Here I wrote electrochemical cutting, chemical grinding, ECC, ECG, electrochemical, in order at least you have some idea about different abbreviations, quite typical in English. Electrochemical cutting, electrochemical grinding, but also they have electrochemical etching. And example of electrochemical etching we see right now. The tool, it's somehow similar to electrodischarge machining, but without liquid practically, not in the bath with liquid, you see. But those nozzles that we see, they supply the dielectric immediately to the zone of processing. I even have found for you to show some schemes before for not that one, not that one, but should be here. Oh, no, not that one. What, for instance, the electrochemical, something similar to what we see. No, there it's electrochemical grinding. They use grinding wheel to remove layer of material, and nozzle supply electrolyte, as you might see. Yeah? And let's come back to slide. Here is what example of electrochemical etching result. Well, what is? How do you think? It's wire edema. Why we do not see the liquid, some bath with liquid? Because it's already no, it's not already. You see, it's somewhere inside of this container, and it's with special clamps fixed in proper position, and next it's will be subjected to this processing. Here is the scheme of electrochemical grinding once again. Вот. And once again, you see comparison, no, like in progress. It's maybe used practically for the same thicknesses. No, not practically for the same thicknesses. Well, laser, it's usually whether it comes about welding or or it comes about cutting. Laser more recommended for delicate work, let's say. And plasma arc cutting, the EBM machining, it's recommended for for more heavy work. But together with this, electron beam machining, it's able to work with thinnest work, with finest work at all. Well, and I forgot again one more group. I changed this table sometimes, people, and I forgot one more group. Thanks to slides, I now see that I forgot one more thing. No, about heat methods, I already said you. It's like over melting of material with removing it with jet air, for instance. And one more technique is here, and this one more technique is called ultrasonic. Oh my! People have invented so many things. You see, time it should be not later than 11. It's 5 minutes yet at least. ultrasonic cutting. It's maybe ultrasonic cutting and ultrasonic welding. And what is idea of this cutting? This tool, it will move in direction of cutting. It just move, but together with it, it's trembling. It's oscillate in this direction. In normal direction, it's oscillate with very high frequency, higher than we may hear. But literally, we may hear it, and it's so ugly sound, I would say. Whew. And some portion of the sounds we hear. It means that it's work with frequency higher than 20,000 hertz, 20,000 oscillations per second. Really, we don't hear all this sound, but some tracks of the sounds that we hear, extremely unpleasant, I would say. But both ultrasonic welding and ultrasonic cutting, they able to work with any material. I place it here on purpose. What do you see? Cheese, biscuit, cookies. It's may be used for cutting practically of everything, fragile, of any material, in any conditions, no problem. And it's very simple equipment. It has this cutting knife maybe of different shapes. We will see it right now. It's already for metal, you see, ultrasonic cutting machine. Depending on the knife shape, depending this intruder shape, you will have either just cut or hole of specific shape or whatsoever you need when it comes about cutting. And once again, it's oscillate in directions that normal, not in direction of cut, let's say, in directions that normal in cut direction, perpendicular to cut direction. And usually this equipment is cheap and rather simple in using. And also it's unpleasant, yes, but plasma arc cutting also, not cutting well, but plasma arc welding, it's accompanied also with extremely unpleasant sounds. Well, and what I haven't shown you yet. Okay, maybe all the pictures that we need to see we have seen already. Now, what I didn't say about this conventional, non-conventional cutting workpieces. Workpieces, maybe any. You may work with sheets. For instance, the same shape that you may cut by shear cutting, mechanical grope, shear cutting, the same thing. In case you ever open it mentor already, the same thing you may do by wait, disappeared somewhere here. Wait a second. Oh, here is. You see something like sheets, and do pay attention. No, I'm not sure it's ideally visible for you. I hope you see it's not one sheet, it's stack of sheets here. Some sheets all together being clumped and placed to the table of milling machine. Such a milling machine for cutting of sheets, it's called router. However funny it sounds, in English it's called milling router. Let me to show. In order we understand the milling router, the difference between conventional milling machine and milling router. Milling router, it's two-dimensional milling machine, you see. Что ты мне показываешь, зверюка? Oh, what's class? Just crying. Look at this. Okay, it's not the subject of our conversation right now. Milling router, no, let it be this one, for instance. It's little, not visible. Oh, milling router whatsoever, it has, thank you, it has table, and this table it's immovable, but over the table it's moved so-called gate, and on this gate in this transversal beam it's moved spindle of machine. So this motion of gate combined with motion of spindle along the gate, altogether it's resulted in two-dimensional motion. If you're cutting the sheet, you don't need any complex machine that able to do complex motions, but you need a lot of space for placing the workpiece. Or those two-dimensional cutting milling machines, which are called milling router. They are purposed exactly for cutting from sheets, but they usually used for cutting some metal sheets simultaneously in order to save time, quite clear. Some sheets and you have the same parts in case you have programs that may be covered by these some sheets, in case you need some of them, not the only. And look at this. Sheet is used in the most effective way. Of course, they place it, not employee, but engineers who created this layout of parts in one sheet. Of course, everything is placed as tight as possible, but pay attention to this fact. What is the wastage already made? It's already chipped, transformed into chip. What is the width of cut? As I said, you diameter of mill at least equal to the thickness of workpiece you're working with, better twice thicker for the stiffness of mill, in order it's not deviate while cutting. And to compare it with what we have seen here. What is thickness of cut? Nothing. No, practically nothing. What is thickness of cut when it comes about water jet? What is thickness of cut when it comes about wire EDM? Nothing. In comparison to conventional milling, for instance, it's nothing. If possible, something to do by shear cutting in a die seems like it's better because you may cut no, literally in a second. Yes, you will cut in a second, but first it's preceded with some months of preparation and money invested into this. Despite of milling, which you may start literally, like the whole day, maybe you spend the whole working shift engineer spent for developing for some programs for this milling machine, and next milling CNC rotor start work, no problem. One day, if it's enough. Some 3D models of parts, 3D model of sheet layout, and you're already working. In contrary to shear cutting by dies. But shear cutting by dies and manufacturing very quick, and manufacturing by milling of the same shapes will be already much more slower because mills move with the speed some tenths of millimeter. Like for instance, aluminium 40 meters per hour, approximately meters. No, yes, if I'm not mistaken. No, what do I mean? It's slow process comparatively to the die. But on other hand, if we need, where we need it, here is, if we need big shapes like ribs, for instance, or webs of ribs, or webs of spars, of big passenger and cargo airplane, size of die is enormous in this case, and it's not rational to use dies in this case. And wherever it's possible to use conventional machining, of course, it will be used conventional machining. Whether it's shear, shear cutting, conventional cutting by blades, single point or multi-point, their abrasive cutting, wherever it's possible, better to use them. All the additional techniques like heat techniques, electrical techniques, electromechanical techniques, whatsoever, it's already for special cases when we either working with hard material or with fragile material, heavy melted material, or it's some shape which is like unbearable for conventional milling, for instance, and so on. What is seems like additional in this chain, in this general transformation chain. It's a period not because of people have nothing to do. It's a period because people were not able to solve the task that we face with conventional techniques. And that is why has appeared these additional techniques. Well, in the book of Michael Grover, those who interested will find enormous amount of information. No, it's not Michael Grover, it's Fedotov. I just have shown you where it started. It's chapter 21, but next it's 22 and 23, if I'm not mistaken. It's a pity that it does not show the whole content here. 21st yet about turning, or 22nd. Chapter number 22, it's also already about machining operations and machining tool. And next, some chapters will be about non-conventional machining. So if you need some broaching by the word, you see the holes and shapes being available by broaching in manufacturing. Try to imagine how to do such slots, for instance, or holes by conventional machining if it's necessary to do it in massive parts. And next, 23rd, 24th, it's still about their cutting tool technologies. No, that is already for advanced things. It's about the tool itself. Tool, about tool product life, and so on. And next one, let's see. Once again, not recommend you to study something by heart, but if you already have in your university your students already of elder years, and maybe you already study some advanced things that we are studying something like for kindergarten, for first year, and economical considerations, somewhere it will be non-conventional machining, abrasive machining. Oh, here is at last. We have found it. Non-traditional machining, it's called here. Non-conventional machining, it's maybe called in another place. And additionally, about non-conventional machining, I will send you something like short essay. I have a lot of books about machining. No, so happened, you understand, about sheet stamping, about machining. But in my opinion, for overview, something like solving the processes, this book, it's more than enough. And what we were trying to do together with you, it's like to arrange all those various techniques in something like a system. No, succeeded, not succeeded, we'll see later. And one thing I forgot to mention once again, subtractive techniques we have solved somehow right now quickly. But there are also additive manufacturing techniques. And if you see, I'm not even trying to do something here. I just left here 7 classes, and each of class have some sub-processes. Altogether, it's around 25 different techniques in additive manufacturing machining, according to modern European and American standards that have been adopted already more than 10 years ago. Let's stop on this, our record, to continue and to finish our lecture classes about manufacturing in the next class.